right, now the other way. Let's find the vertex, focus, and directrix of a parabola given by this equation. So we look for HK. You all are adept at that now, I hope, H and K. So we have a vertex at 3, -1. 3, -1. And then we know the direction of this one is x squared and it's positive, so it's up. We know 4p equals 8, so p equals 2. So if we go 2 units up, 2, we get the focus, and if we go 2 units down, we get the directrix. Opening up. So 2 units up would be 3, -1 plus 2, so 3, 1. And the directrix is -1 down 2, or y equals -3. This is horizontal. Okay? Yay! All right, now, then they're going to give us those that we have to complete the square, and you've completed the square on 2 different squares, so now we're going to complete the square on just one. It's a little easier. So we're going to move the 14 over to the other side, and we get 8y plus 14 equals 2. Go ahead and factor that 2 out. X squared minus 6x. And then, let's see, that's going to be half of 6 is 3 squared plus 9. But with 2 times 9 to the other side plus 18. So we get 8y plus 32 equals 2 times x minus 3, condense it down, squared. And then 8 times y plus 4 equals 2 times x minus 3 squared. And then just divide. 4y plus 4 equals x minus 3 squared. And you have your completed equation. I don't guess we needed to graph anything on this one, so yay. Oh, vertex, we got to find all that stuff. Yeah, we did. So, vertex. What do we got? Well, 3, -4. Focus. 4p equals 4, so p equals 1. And what's our direction on this one? X is squared and it's positive, so this one's up. So let's see, 3, -4, right here. We're going to go up 1 to get the focus as it's opening up, and down 1 to get the directrix. So our focus is up 1, so that's at 3, -3. Our directrix is down 1, so that's y equals -5. And then you have it all laid out for you. All right. All right, our applications. Applications of parabolas are all kinds of things. A suspension bridge is this, and it's suspended, the cables are suspended from posts or towers. An arch, a bridge arch, would be like upside down, like that one. Cookers. A cooker would No, those aren't lights. A cooker would have a parabolic mirror that would focus the rays in and cook. The same thing for a light. If you look at the flashlight on the inside, you'll see a curved surface behind it that's focusing. It's parabolic, focusing everything to the focus. So lots and lots of satellite dishes do the same thing, sending all of the things to the focus. All right, so here's our example. We're going to do a solar cooker, and we have a parabola that is 6 feet wide and 1 foot deep. Where do we put the cooker or the focus? Okay, so always remember that you want to stick this on an axis, and it's a parabola or part of a parabola, and you're always given a point. Now, they don't tell you right off the bat that that's a point, but it's over 3 feet and up 1 feet, so it is a point, 3, 1. And we're going to put it at 0, 0 to make life easy. And then the question is, where's this focus? All right, so we have the equation. We know it's 0, 0 at the center. We know it's opening up to make it x squared. So we know it's x squared equals 4py. And they were like, oh no, now what do I do, Miss Pointer? There's nothing there. Well, you do know something else. You're given that point. There's always a point given to you somewhere. And since you know that point, you know an x and a y. So we just plug in our x and our y. So we have 9 for 3 squared equals 4 times p times 1. Solve for p. We get 9 over 4 equals p. So that's what, 2 1/4? 2 1/4 feet from the vertex is where you need to put the cooker. Okay? All right. So have fun with parabolas. They're our last conic section. Enjoy.